Hello everyone, so today's topic is electromagnetic waves. So let's start off by what are electromagnetic waves? They are waves that are created as a result of vibrations between an electric and a magnetic field. In other words, EM waves are composed of oscillating magnetic and electric fields, just as shown in the figure below. Electromagnetic waves transfer energy. So, all types of waves, whether they are mechanical or electromagnetic, have an energy associated with their motion. The energy carried by electromagnetic waves can be transferred to objects in the path of the waves or converted to other forms such as heat. The energy transported by electromagnetic waves is called electromagnetic radiation. So, the electromagnetic spectrum is the entire range of wavelengths or frequencies of the electromagnetic radiation. We can memorize the spectrum by this sentence. Ronald McDonald is very ugly except Gary. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. We can see that they are ordered from the longest wavelength to the shortest wavelength, from the lowest frequency to the highest frequency. So the first wave here is the radio waves. Radio wave is an electromagnetic wave with a frequency between 100 squared and 100 to the power of 6 Hz and is used for long-distance communication. Naturally occurring radio waves are made by lightning or by astronomical objects. Artificially generated radio waves are used for fixed or mobile radio communication, broadcasting, radar, and other navigation systems. The figure on the side explains how we receive the radio information. Microwaves. Microwaves are a form of electromagnetic radiation with frequencies between 300 MHz and 300 GHz. Microwaves are used in spacecraft communication and much of the world's data. TV and telephone communications are transmitted long distance by microwaves between ground stations and communication satellites. Microwaves are also employed in our homes, in the microwave ovens we used, and in radar technology. So microwave ovens, just as the one shown in the figure on the side, uses microwaves to heat the food that we put in there. Moving on to infrared waves, or IR, sometimes called infrared light, is electromagnetic radiation, and its wavelength extends from the nominal red edge of the visible spectrum at 700 nanometers to 1 millimeter. It is therefore generally invisible to the human eye. Although IR at wavelengths up to 150 nanometers from specially pulsed lasers can be seen by humans under certain conditions. One of the most common uses of infrared radiation is in heat-sensitive thermal imaging cameras. These can be used to study human and animal body heat patterns, but more often they are used as night vision cameras. The figures on the side show us the different temperatures in the human body. Visible light. The visible light spectrum is the segment of electromagnetic spectrum that the human eye can view with wavelengths from 380 to 700 nanometers. The sun produces visible light. Light bulbs, fluorescent, and neon lights are other examples of visible light that we may see on a regular basis. So, the sun actually produces white light, but when the light passes through a glass prism, we see that the light is actually composed of 7 different colors, starting at violet up to red, and those are the ranges that we can see. Sometimes when it rains, we see the rainbow, where the water droplets in the air act as the glass prism. That's why we see the rainbow. Moving on to ultraviolet waves, or UV, is an electromagnetic radiation with wavelength from 100 nanometers to 400 nanometers. Ultraviolet rays can be used to kill microbes. Hospitals use UV lamps to sterilize surgical equipment and the air in operating theaters. Food and drug companies also use UV lamps to sterilize their products. So we actually get UV from the sun, but we also artificially generate it and use it to sterilize many things, from food to surgical equipment. Now, X-rays. X-rays make up X radiation, a form of high-energy electromagnetic radiation. Most X-rays have a wavelength ranging from 0.1 to 10 nanometers. A very high radiation dose over a short period of time causes radiation sickness. while lower doses can give an increased risk of radiation-induced cancer. One of the most common cancers that is caused by harmful radiation, especially X-rays, is leukemia or blood cancer. The most familiar use of X-rays is checking for fractures or broken bones, but X-rays are also used in other ways. For example, chest X-rays can spot pneumonia. Mammograms use X-rays to look for breast cancer. I'm pretty sure most of us have seen X-rays, just as the ones in the figures on the side. Now moving on to gamma rays. A gamma ray or gamma radiation with symbol gamma is a penetrating electromagnetic radiation arising from the radioactive decay of atomic nuclei. It consists of the shortest wavelength, electromagnetic waves, and so imparts the highest photon energy. Gamma rays are used in medicine for radiotherapy, or industry for sterilization and disinfection, and the nuclear industry. As we can see in the figure on the side, the gamma rays are used to target the cancer and kill it. Thank you for listening to me in today's video. So since we